Hello, we are back outside. So today we start the huge topic known as factoring. We know how to do this. Remember, 3x is technically a polynomial. It's also just a monomial, but you know how to multiply it out. You just use the distributive property. So 3x times x minus 5 is 3x squared minus 15x. So equality works both ways. So all factoring really is taking this second expression, 3x squared minus 15x, and writing it as this first expression. We want to do that backwards. And at its most basic, factoring is just using the distributive property backwards. But we have to lay a little bit of groundwork before we start doing that. So I could take this and say, what I'm going to do is I'm going to take a common factor out of each term, which we'll go over in detail. I just want you to see what factoring even is. I could say that. So you don't have to know how I did it, but just agree with me that if you were going to multiply it back out, you'd say, okay, this is 6x squared, and this is minus 10x, right? So I did that by taking out a factor of 2x. And I can take out any factor I want, but specifically I want to take out as much as I can. So I want to take out something called the greatest common factor. So the instructions now are going to be like, here's a polynomial, factor it. What that means is to write it as the product of two or even more than two other polynomials, like smaller polynomials. Okay, so here's the definition of the greatest common factor. It's the largest polynomial. So the greatest common factor of a polynomial is the largest polynomial that divides evenly into every term. So you can think about it as a divisor. It's like the greatest common divisor of every single term in the polynomial. You have to be able to take it out of every one for it to be a factor. And then there's just always going to be a unique one that's this thing, the greatest common factor. So being lazy mathematicians, from now on, we'll just write GCF. Let's just do it with a couple of numbers. Remember, these 16 and 24 technically are polynomials because they're monomials with no x component. So here's just a surefire process of doing it every time. Now you might be able to look at these and just say, these both have a factor of 8. Isn't 8 the greatest common factor? Actually, yeah. But I want to show you a process by which you can do it no matter what. So this kind of takes us back to some old stuff. We want to find the prime factorization of both of them. So 16 is just a bunch of 2's. It's 2 times 2 times 2 times 2. And then 24 is going to be 2 times 2 times 2 times 3, right? Okay, remember those? Now we find every possible common factor they have. It looks like this one has 3 factors of 2 and this one has 3 factors of 2. So all of their common factors are those 3 factors of 2. So multiply those 3 common factors together. Multiply all the common factors, common prime factors they have together, and that gets you the GCF. Okay, so it's 8, which is what you thought, right? But this is just a kind of a foolproof way to do it. So the more you do this, the more you'll be able to look at it and just say, okay, this is the most we can possibly zap out of both things. So we can do the same thing with monomials that have like an x in them. We can do it with more than one. In fact, in general, we want to be doing it with more than one. So let's find the greatest common factor of 6x to the 5th, 12x to the 4th, and 15x squared. So you can do this in like 2 separate parts. You'll find the greatest common factor of 6, 12, and 15, and then you'll find the greatest common factor of x to the 5th, x to the 4th, and x squared. So 6, 12, and 15, remember those are called coefficients. So maybe you can look at 6, 12, and 15 and just kind of think about what kind of factors they all have. 15 isn't going to have any even factors, so it's really just 3, right? 3 is the only thing they all have in common. But if you do the prime factorizations, you'll see that. The only thing that all 3 numbers have in common is 3. So that's it. There's nothing to multiply, so 3 is the greatest common factor. And then it's a little different when you look at x to the 5th, x to the 4th, and x squared. Just think about what those exponents mean. X to the 5th is x times itself 5 times. X to the 4th is x times itself 4 times. x squared is x times itself 2 times. So like the prime factorization of x squared is just x times x. So every one of those things has at least 2 factors of x in it, right? This has 2, this has 4, this has 5. So the most you can possibly take out of all 3 of them is going to be 2 factors of x. So here's like the general rule. You look at the lowest power x squared and you say x squared is a factor of itself, and it's also a factor of x to the 4th, and it's also a factor of x to the 5th, right? Because x to the 5th is x squared times x times x times x. So that's it. So if you have a bunch of powers of x, the lowest power you see of it is the greatest common factor of all those powers, because by definition it goes into everything else and it goes into itself. Okay, so we've got the 3 and we've got the x squared, so the greatest common factor is 6x to the 5th, 12x to the 4th, and 15x squared is 3x squared. And just verify in your mind that you could divide that out of every single one of these terms. And we're about to do that, but you have to be able to do it. Like if you divided 3x squared out of 15x squared, you'd be left with a 5. For this, you'd be left with 4x squared. For this, you'd be left with a 2x cubed. So it's like what you're left over with kind of becomes important too. But if we do it in this kind of rigorous process, we know that we in fact have the greatest common factor, the most we can possibly divide out of all 3 of these terms. Okay, let's do it with these. These are expressions, they are polynomials, but for now just think about them as just a bunch of stuff multiplied together. So it's kind of the same thing. You look for any possible factors they could have. This one has a factor of 3 and this one has a factor of 6, which means there's a common factor of 3. This one has an x plus 2, but this one doesn't. This one has an x minus 4, as does this. This one actually has 2 factors of x minus 4. So you can just basically look at the first expression, and it's like a prime factorization. Its factors are 3, x plus 2, and x minus 4. Do the same thing for the second expression. The factors of the second expression are 2, 3, right, because of the 6, x minus 4, and x minus 4. So that might seem redundant, but it has 2 factors of x minus 4. So then you just look at anything they have in common and multiply those together. The only things they have in common are the 3 and 1 copy of the x minus 4. Okay? So 3 times x minus 4 is their greatest common factor. Okay, so sorry, the GCF is 3 times x minus 4. So it's like you look at the constant terms and then you look at the x terms. But now we're even doing it with like binomials. This one has a factor of x minus 4, so does this. All right, so now we're getting to actually factoring a polynomial. At its essence, factoring is doing the distributive property backwards. Okay, so bear with me. I think factoring is kind of fun. And like it or not, it never really goes away. So this is pretty important. All right, so here we go. So the instructions are just factor. Factor 7x squared minus 14x. And that's kind of shorthand for like fully factor or just you have to find the greatest common factor between these 2 terms and take it out of there. Okay, so that's the first step. Find the greatest common factor of 7x squared 14x. So I just said that it's 7x. So that's the process we've been doing over and over again. The greatest common factor of 7 and 14 is obviously 7, right? Because it goes into 14. And then by the same token, the greatest common factor of x squared and x is just x, because it goes into itself and it has to go into x squared, or it's just the lowest power you see. So that's it. So it's 7 times x. So now take each term and write it as the product of 7x and something else. So this is just like factoring a number. If you factor 5 out of 20, you're going to get 5 times 4. So now you're saying, okay, 7x squared is 7x times what? And negative 14x is 7x times what? What's left over? Well, it's that. So it equals 7x times x minus 7x times 2, right? So, right, it's like doing a thing that we've already done backwards, and that's like the story of math. You get good at something, and then your instructor says, okay, now do that same thing backwards. Okay, so now you use, again, the distributive property, but going the other way. So just bear with me, and then we'll see if we all agree. like that. So that's it. That's fully factored. So just verify that you believe this. If you were to distribute this back out, you'd get, okay, this is 7x squared minus 2 times 7x, which is 14x. Right? They're the same expression. So we didn't really change it. We just wrote it in a different form and what we would call its fully factored form. There's nothing else you could take out of there. And you know, because this thing x minus 2, x and 2 have no common factors. If they did, we'd actually have to keep going. But if we just stick with this greatest common factor method, we'll be fine. Okay, so do what I just kind of did. And I would encourage you to do that for now. Actually do it. Distribute it back out. Just so you can see, oh, it really works. It's the same thing. Oh boy, looks harder, but it's really not. There's just more stuff. So you're going to look at the coefficient part, 4, 10, and 18. Well, think about it. 4, 10, and 18 are all even, which means they all have a common factor of 2. And you think, well, do they have a factor of 4? No, actually, 18 is not divisible by 4, so that's it. That's as good as you're going to get. So the greatest common factor of the coefficient parts is 2, and then you look at the variable parts. And now we got an a and a b. Oh my gosh. So you just look for the smallest power of a. The smallest power of a happens here. It's just a to the 1. And then you look at the smallest power of b. The smallest power of b you see is b squared. So that's going to be the most you can factor out of every term. You're going to be able to factor an a out of every term, and you're going to be able to factor a b squared out of every term. Okay? So it's going to be 2ab squared. All right? So it's a little different process for numbers and with coefficients. But the more you do this, you'll get pretty fast at it, I promise. Okay, so take it out. So take it out of every term and then just think about what remains. So let's think about it. So when you take 2ab squared out of this first term, you're left with a 2 and an a. When you take it out of this second term, you're left with it's like a negative 5 and a b. And when you take it out of this third term, you're left with a 9a squared b squared. Like that. So it's like in this first step, it seems like you're kind of making it more complicated. So this first term is 2ab squared times 2a, then it's minus 2ab squared times 5b, then it's plus 2ab squared times 9a squared b squared. Phew. All right, and then you take your common factor, the greatest common factor that we found, and just reverse distributive property it and bring it out front. Like that. And now we have to be careful because this negative sign stays with the 5b. Right? If you were to multiply this middle term out, you'd have 2ab squared times minus 5b, which would be negative 10 ab cubed, which is exactly what you want. Okay, so the whatever remains stuff goes in here. So here's your 2a minus your 5b, and then your 9a squared b squared. So a couple things to check, like if this still seems new and iffy, just multiply this whole thing back out. Do it. I want you to do it. And then you'll see once you multiply it out and combine like terms, right, you just have what you started with. This is just what we call it in its fully factored form. And then look at what we have left over, these leftover terms. We have a 2a, a minus 5b, and a 9a squared b squared. None of those should have any common factors, and they don't. Right? They don't. If they did, then you would not. You would know that, oops, I didn't actually take out the greatest common factor. Okay, so that's another must. We have to not have any common factors left over in here. We took them all out. Here's a little simpler one, but I just a trick I have to show you. See how the first term is negative. So the first term, the polynomial is in standard form with like descending powers, but the first coefficient is negative. So we actually consider that negative kind of part of the factorization and factor it out. So you could look at it and say, okay, the greatest common factor between these two terms is 5x. But we actually want it to be negative 5x. So we consider the negative a part of the factorization. Okay, so if you just factored 5x out of it, you'd get something, but this is just better. It's just considered a better way to factor it. And you'll thank me later. Okay, so take the negative 5x out of the first term, you get negative 5x times x squared, and then this is a little tricky. When you take the negative 5x out of the 10x, you're actually left over with a negative 2, right? Because it's like you divided a positive number by a negative number, so what you're left over with is a negative number. And once we take it out, just look at it and verify that it works going back the other way. All right, so the factorization is negative 5x times x squared minus 2. So just kind of look at it. If you distributed this, it'd be negative 5x cubed, and then it'd be minus times a minus, which is a plus 10x. Okay, so just something to look for. When you see the first term being negative, take the negative out as well. It comes with the 5. Okay, so we're leading into something here, a trick called factoring by grouping. We have something that's laid out kind of weird, and you don't want to start actually multiplying this stuff back out and distributing it. That would be counterproductive. But just look, you have two terms here, 4x times x minus 3 and 5 times x minus 3. 4x and 5 don't have any common factors, but both the terms have a factor of x minus 3, so we can take it out of both. So do it. And that's what you're left over with. So this is kind of like, that kind of should remind you of FOIL. That seems like the kind of thing we would FOIL out. Now don't, because we're not going that way, we're going this way. So that's factored. So if your two terms have a binomial factor in common, you can take that binomial out. There's nothing that says you can't. And then here's your first big factoring technique. It's called factoring by grouping, and it's tricky. So be sure you're with me and be sure you do some of these examples. So diving right in, I'm going to factor x cubed plus 4x squared minus 2x minus 8. Okay, so you look at all four terms like we've been doing and you say, well, there's no common factor, right? There's no common factor at all. You think, oh, is there a 2? No, because there's no 2 here. You think, oh, is it an x? No, because there's no x here. So notice that there's stuff you can factor out of some of the terms, but that's not really what we've been doing. We've been saying it has to come out of all the terms. So this is the first time when we're saying we're factoring something out of some of the terms and something else out of something else, but it has to be done a very specific way. So you look at the first two terms and the last two terms. The first two terms, x cubed and 4x squared, do have common factors. In fact, they have a greatest common factor of x squared. The second two terms, minus 2x and minus 8, also have a common factor. And the greatest common factor of those two would actually be negative 2, because remember we zap out the negative 2. So this has a factor of negative 2, and this has a factor of negative 2, okay? So when you see factor by grouping, this is it. This is the only way to do it. First two terms, second two terms. So it's a very specific thing. Okay, so go ahead and do that. Take the GCF of the first two terms is x squared, factor it out. The GCF of the second two terms is minus 2, factor it out. So that was a big step. So stare at that for a second. Pause the screen. Be sure that you agree that I can do that. Right? I mean, I can do whatever I want, but be sure that you agree that I can. So by doing it backwards. So this is x cubed, right? Distribute, plus 4x squared, minus 2x, and then minus 8. So it worked. By taking the minus 2 out, what we're left over here with is an x plus 4. Okay? So that's the big move. If you're comfortable with that, then that's factoring by grouping. We're not done, but look at where we are, and then look at the example I just did. You see how now we're back to a place that's very similar to this place. So now we have a expression with two terms in it, and they have a common factor of x plus 4. And that's the key. If you did that factorization and they didn't have a common factor, like if this were an x plus 3 instead, it wouldn't have worked. This would not be a factoring by grouping problem. You know what I mean? It would be some other kind of problem. So, and I wouldn't trick you like that. So it better be the same term. Okay? So now do what we did before. They have a common factor of x plus 4. No reason you can't. So that's the greatest common factor. So take it out. Emphasizing. That was important. Okay, so it has to have a common factor for this to have worked. And it did. So you factor the x plus 4 out front, what you're left over with, the x squared and the minus 2. And that's it. That's fully factored. So that's factoring by grouping. That's different, right? That was a different way than everything we did thus far, but it's like doing that, it's almost like just doing it twice. You do it once out of the first and last terms, and then what you're left over with has to be the same factor, so then you can factor that out. We're actually going to FOIL it out, because it's important that you believe me. This is the only example I'm doing, so FOIL it out. X times x squared minus, or plus x times negative 2 plus 4 times x squared plus 4 times negative 2. Multiply all that junk together. You get x squared minus 2, or x cubed minus 2x plus 4x squared minus 8. And then you look back at the beginning. Well, it's not exactly what we have. It's in a weird order, but that doesn't matter. So it is what we had to begin with. Okay, so that's important. So that's like the biggest algebra move I think I've showed you so far, is factoring by grouping. Next, we get into the kind of factoring that you might be familiar with, which is like unfoiling trinomials. But this might be new to you, and if it is, you have to just try the ones on the homework, because that is tricky. And if you're good with that, then you're good at algebra. Okay, that's it. Thank you.